Hello and welcome to the very first instructional video lesson for pre-calculus algebra, section 41, math 170, 141, fall 2016 here at Western Piedmont Community College. Like I say, the very first one of many of these. There will be one of these, at least one of these videos will cover every section in the text which the course encompasses. Sometimes, occasionally, a couple sections will be covered in one video together, but the point is every single section will have some instruction, some actual teaching you can listen to and observe what's happening on the screen to accompany that section. So I always recommend that you watch these videos before actually attempting the homework assignment for that respective section. And again, this is the very first one, section 1.1 in our text concerning graphs of equations. And I want to emphasize with you, as you probably noticed on the first page of the syllabus to this course, when it spoke of the calculator for the course, it said the TI-84 calculator or Desmos is preferred. And I am honestly encouraging everybody, if you're not used to this, to if you haven't used it before, to discover Desmos, and we will be using that in this video right here. If you've used it before, I trust you've found how amazingly effective and helpful it is. So much more efficient than using the Texas Instruments graphing calculators, which of course, yeah, they'll do the work for you. But there's, for instance, you have to always solve the equation for y before you can graph it. You have to labor so much very often to get the correct window to be able to see the portion of the graph you're interested in, and such as that. Desmos makes many things much, much easier, and I highly recommend it. Not only do I encourage the use of Desmos when you're doing your homework, you're certainly allowed to use Desmos when you're taking your tests. And you will have access to Desmos on a computer even when you're taking the course midterm exam and the course final exam, those two exams of course being proctored, but you are allowed to use that graphing utility on a computer even for those exams also. So let's begin right here then. When we speak of the graph of an equation, let's talk about what we mean. What is an equation? Well, in this course, we're going to have equations of two variables very frequently, most frequently the two variables x and y, and most frequently again where y is a function of x. And these equations with two variables qualify for being an equation, of course, if and only if there's an equal sign in the mathematical statement. During this course, we will be working with not only equations, but also inequalities. We will be graphing inequalities, solving inequalities, working with inequalities, but the primary portion of the course is going to have to do with equations. So that's where we're starting off. And an equation simply represents a relationship between two different quantities, two different variables. And if you have just the right numbers, so to speak, for x and for y, to plug in for x and to plug in for y, that makes the equation true, then that ordered pair of the x value and the y value is what we call a solution point. It's a solution point on the graph of that equation. So if you have an ordered pair like 3, 4 in parentheses happens to be the a solution point for an equation, for instance, 3, 4 would be a solution point for the equation y equals x plus 1. The straight line y equals x plus 1, the y-intercept of 1, slope of 1. When x is 3, y is 4. So one of its infinite number of solution points is the point 3, 4. 4 comma 5 would be a solution point, 5 comma 6, 0 comma 1, all those in parentheses would also be ordered pairs that we would accurately call solution points for that equation, y equals x plus 1. Now you're going to have some homework problems starting off this section where you simply have to verify whether or not a particular ordered pair represents a solution point for the equation. And this first example in this section illustrates this. They ask us to determine whether the ordered pair 213 and also the second one, -1, -3, lie on the graph of y equals 10x minus 7. Well, if we plug those numbers for part A, the 213 ordered pair, if we plug in 2 for x and 13 for y, and then we do our arithmetic and see if we get a true result or not. And of course, plugging in 13 for y on the left and plugging in 2 for x, we get 13 is it equal to 10 times 2 minus 7? Doing our multiplying before subtracting, basic order of operations, 13 equals 20 minus 7. So yes, we do end up with 13 equals 13. Now, the point of this class is not that 13 has some intrinsic meaning to it. No. In fact, it's strictly coincidental that we got 13 equals 13, and 13 happens to be one of the numbers in the ordered pair. That's strictly coincidental. It could have ended up 10 equals 10, or -5 equals -5, or 0 equals 0. The point is, as long as it's a true statement, the number on the left is the same as the number on the right, so they truly are equal, then we have discovered an actual solution point on the graph of this equation. We've discovered a solution pair, you could go solution ordered pair for the equation. So yes, the answer is yes. The ordered pair 213 represents a solution point on the graph of y equals 10x minus 7. The second one, -1, -3, when we plug in -3 for y on the left and -1 for x, we get -3. Is it equal to 10 times -1 minus 7? Well, 10 times -1 is -10. Take away 7 more, it's -17. And clearly not. -3 is not equal to -17. Again, the point is that we ended up with a statement that is not true. It's not there's nothing special about the numbers -3 and -17. The point is they are different numbers, so they are not equal. It's not a true statement to say that they're equal, and that was forced upon us by plugging in -1 for x and -3 for y. We ended up with just doing the arithmetic, trying to equate -3 and -17, which is not difficult, as I like to say. It's impossible. And so therefore, the conclusion, the point -1, -3 does not lie on the graph of y equals 10x minus 7, and therefore it is not a solution point for that equation. Quick comment right here, we do not have the availability of the iPad technology with this lesson, so we are going to, as far as what's on the screen, it will be various portions of the text and various illustrations in Desmos or the TI-84 simulator. So now the text here for the next couple pages really talks a lot about graphing by pointing plots. They give you this little box down here and they talk about this. I imagine every one of you, as well as myself, has had some experience with sketching graphs by point plotting, and that's perfectly fine. It's nothing, I mean, that's an excellent thing to do. But I want to suggest that literally in today's environment, 21st century technology available to us as it is, graphing by plotting points is becoming almost a skill of the past. It's just not that significant anymore. So I'm not really going to emphasize this or spend much time on this at all. Like I say, if you've done a whole lot of this before, that is a very excellent background to have for your graphing work. But I'm just not going to spend a lot of time talking about this because I don't think it's that essential with what we have available to us now. And what are you going to be doing in this very first section? For instance, in the homework, you're going to be asked to graph quite a few different equations with the x and y variables. Some of them will be solved for y in the sense that the equation will be y equals then on the right side some expression in x. It could be 2x plus 3 or 5x squared minus 4 plus 4x plus 2 or whatever. Whatever the expression is, the y will be by itself. And then you'll also have some equations that are not given to you that way. It might be given to you like 2x plus 3y equals 12. The equation is not solved for y. With 2x plus 3y equals 12, to solve that the traditional way, for y, so that you can graph it on a Texas Instruments graphing calculator like a TI-83 or a TI-84. You would have to solve it for y and then graph it. This equation that we see right here on the screen, and that's still true. The Texas Instruments graphing calculators have not changed their program such that we can avoid having to solve for y. We still have to solve for y. And we'll illustrate this here in just a little bit. But even this equation right here on page 76, a basic, pretty simple equation. This is 3x plus y equals 6. And we can illustrate this right here, the difference between Texas Instruments graphing calculators and Desmos. If you're plotting it on paper as they illustrate here, well then yes, you got to plot a lot of different points and go from there. But let's say you're going to do this with technology. And we'll do it the old-fashioned way first with a Texas Instruments graphing calculator. To graph 3x plus y equals 6, I'm going to see, I think I can use a utility on here and right on this screen. I'm going to attempt that right now. With the 3x plus y equals 6 equation, if we were to subtract 3x from both sides, then we would, yeah, this is going to work here. We can get y equals negative 3x plus 6. Y equals negative 3x plus 6, which is just simply an algebraically adjusted different form of the original equation. It has the exact same set of solution points the original equation had, 3x plus y equals 6. But now, since we have solved it for y, we can pull up, this is a simulation of a TI-84 Plus. We can pull this up now and use this to graph this. So let's do this. And by the way, the size of this TI-84 Plus on the screen is not adjustable. It's a fixed size. So let's do this. First turn the thing on, go to y equals, and input negative 3x plus 6. I trust you'll recall when your very first character in a string that you're entering into the TI-84 is a minus sign, you cannot just use the regular subtraction key over here. You have to use the minus sign with the parentheses around it on this lower right white key right here. So minus and then 3x plus 6, and we should have the standard basic window, x going from negative 10 to positive 10, y from negative 10 to positive 10. That's fine. Now I click on the graph key, and there we have it. The straight line with a slope of negative 3 the number in front of x, since the equation is solved for y, the number in front of x is the slope, -3, and the y-intercept, 6. In fact, let me go ahead and point out how we have put this equation. This is a little precursor to the next lesson, section 1.2, I believe it is, where we have what's known as the slope-intercept form of the equation of a line, y equals mx plus b, and we have actually converted our 3x plus y equals 6 equation into slope-intercept form, and that is now y equals -3x plus 6. So the m representing the slope is -3, and the b representing the y-intercept value is 6. And once again, going back to the TI-84, we have the y-intercept up here of 6. And each time x is increasing by 1, the line is dropping by 3 vertically, and that represents a slope of -3, the rise over run. The rise, so to speak, or the drop actually, is -3 for every 1 of run to the right, -3 over 1, such that starting at 6 on the y-axis, as x increases by 2, just moving to the right 2, y drops by 6, 3 times 2, such that when x equals 2, y is 0. And so we have now both of the intercepts figured out here. The y-intercept for the equation is 0, 6, and the x-intercept for this equation is 2, 0. But let me just make a pretty obvious point here. With the display that the TI-84 gives us, I can point at this display and try to interact with it, and as you well know, that doesn't happen. If I click on the 0, 6 point, nothing happens. If I click on the 2, 0 point, nothing happens. And if I want to change the size or the zoom in or the zoom out of this graph on this window, I have to come down to like the zoom key or go to the window key and actually do some changes to the parameters of this display. And yes, you can quite able to do that, but I'm just reminding you the amount of work that's involved here, because I'm about to show you another way to graph this equation in Desmos. If you've never seen Desmos, I think you're going to like this. If you've seen it before, then you know what to expect. So I'm going to minimize this and bring up Desmos here. And yeah, I need to do some erasing here. There we go. In fact, let me show you how I got to Desmos here. All I did was go to the website desmos.com. Desmos.com. So it is just simply www. Here I'm writing it on the far left of the screen now. Desmos.com. Okay, that's it. That's the website. And when you go to that, you type in desmos.com. This is what comes up. This is their home page. And then you simply click on Start Graphing. And as soon as you do that, let's get rid of that desmos.com here. There we go. All right, as soon as you do that, you get the coordinate plane up here in the upper right, and you get the block over here where you enter an equation to graph, and you get the nice keyboard stuff down here at the bottom, X's and Y's and symbols and numbers, operation keys, and also some really neat stuff under functions. For instance, you got sine, cosine, tangent, all sorts of other things if you need it, EXP, log, ABS for absolute value. That's pretty nice. And some stuff in statistics too if you were needing that. Nice stuff available for trig. Really good stuff available here. But let's just start this out. Okay, there we go. Let's plug in. Here's what I want to show you. That original equation that was presented in that example, 3x plus y equals 6, you just cannot, it's not difficult, it's impossible to graph 3x plus y equals 6 straight out as is in a TI-84. But with Desmos, it's not only possible, it's quite simple. I'm simply going to type 3x plus y equals 6, and there it is. I mean, that is just too easy. So 3x plus y equals 6, and I've got to point this out to you. The y-intercept right up here, you may already be noticing this, apparently it's got a little gray point right there because the Desmos programmers know that many of us, this is the stuff we're interested in. We want to know, where does my graph cross the axes, or where does it cross another graph, and that kind of stuff. And so oftentimes you'll see these little light points designated, and when I go right to that point and point at it, it highlights 0, 6. If I click on it, it locks it in. And now I'm moving the mouse around, and that's locked in, 0, 6. Verifying and confirming that, yes, indeed, this particular graph does have a y-intercept of 6. The y-intercept point in full ordered pair format is 0, 6 in parentheses. Similarly, where it crosses the x-axis, you see the little dot right there too. I'm going to point at it, and very lightly the 2, 0 shows up, but I simply click on the point and it locks it in. So now we have both of them showing. The x-intercept 2, 0 in parentheses, and the y-intercept 0, 6 in parentheses. I have to say this is very nice for so many purposes in math, that they've created this free online graphing utility that is so functional and even more efficient than the TI-84 in so many ways. Well, we can also do this the old-fashioned way, as if you were using a TI-84. We've already done the algebra and converted this equation into y equals negative 3x plus 6. And so now we have 2 right on top of each other. So there you have it the old way, and I'm going to delete the first one now and just leave that one to prove that it really is there. Y equals negative 3x plus 6. So yes, my point is you can graph it either way, any way you want. Solve for y with y by itself on the left equal to the expression in x, or just with y's embedded in there, however you wish to do this. Let's look at some more examples here. Let's say you wanted to graph a circle. Traditionally, to graph a circle, like x squared plus y squared equals 4. Here, let me write this up here. Well, it may not let me do that. All right, I'm trying to, but let's see if I can. Oh yes, I certainly can. X squared plus y squared equals 4. And some of you will recall an equation in that form where both the variables are squared, added together, and equaling of some positive number. That's actually the equation of a circle. The radius of the circle is just the square root of the number on the right, so the square root of 4 is 2. And since there are no numbers being added or subtracted to the x and the y that are being squared, then the center of the circle is the origin, 0, 0, and it has a radius of 2. But to graph such an apparently simple equation with a TI-84 takes some work. You have to convert this equation into just equations with y equals some expression in x with the y by itself. And what happens when you do that, for instance, you subtract x squared from both sides and you get y squared equals negative x squared plus 4. And now to solve for y by itself, you take the square root of both sides, but if you recall, to take the square root of both sides, it introduces two possibilities. Y can be either the positive square root of negative x squared plus 4, or it could be the negative square root of negative x squared plus 4. So you have two distinct possibilities. Y equals plus or minus the square root of negative x squared plus 4, which is actually two equations. Y equals plus the square root of negative x squared plus 4, and y equals negative the square root of negative x squared plus 4. And to graph this circle with a TI-84, you would have to graph each of those equations separately. So you'd actually have to put two graphs on the same screen at the same time using the like y1 equals and the y2 equals in the TI-84 format. But here's the nice part. With Desmos, all we have to do is enter the equation just like it is. So I'm going to click on the X, and yeah, it automatically enters it like it's y equals x, which of course we're going to change that. Now I'm going to click on the a squared key, which is a simple way to square whatever you've just entered. Instead of having to hit the caret key on the keyboard above the 6, the exponent key, and then hitting the 2, all you have to do is hit x squared. That's nice. And plus y, and then I'm going to square it, and then equals 4. And I did it right here on the little keyboard they gave me, but you can also use just the keyboard on the computer either way. So x squared plus y squared equals 4. We have our circle. There it is. Simple as that. X squared plus y squared equals 4. Desmos is programmed to know what to do with that. And it has very accurately graphed it. In fact, now you see there's two x-intercepts and two y-intercepts. The y-intercept 0, 2 and the y-intercept 0, negative 2. The x-intercept 2, 0 and the x-intercept negative 2, 0. So there's two x-intercepts and two y-intercepts for this circle because both the variables are squared, so you're having two of those and at most. You can have two, and we do have two for this one. So let's talk about one more thing before we wrap this up today. You will be graphing lots of different kinds of equations, and I suggest you use Desmos, but of course you can use your TI-83s or 84s also just as well. And then when you go to your homework problems, they're going to give you an equation and say graph this, and since you're not actually graphing it in WebAssign, they will give you several choices of graphs, and you have to simply pick the correct one based on your having already graphed it yourself. You know, okay, this out of the 4 here, this is the right one, and you just pick that one. So you're going to be graphing lots of different equations and picking the graphs. You're not actually going to have to graph it in WebAssign, but simply select the pre-given options they've already got down there for you. You just pick the right one. And the only other thing I believe you're going to be doing in this section in the homework problems is you also are sometimes going to have to find the x and y intercepts of different graphs. So let's talk about this. That's not that hard to do. I want to get rid of this. There we go. Got rid of that now. That's good. All right. I'm also going to get rid of this first equation. Well, no, let's not do that yet. Let's hold off a second. Okay. Talking about finding x and y intercepts. To find x and y intercepts, all you do is set the other variable equal to 0 and solve for the one that you're trying to find. What I mean is, if you're trying to find like the x-intercept for y equals negative 3x plus 6, this top equation, you're trying to find, well, let's start with the x-intercept. If you're trying to find the x-intercept, then you set y equal to 0. And so in doing that, let me get this back up here again where I can write, then you'll get 0 equals negative 3x plus 6. And then you have a simple equation to solve for x. So you add 3x to both sides, get 3x equals 6, and then you divide by 3 on both sides, and of course you find out that x equals 2. That is the value of the x-intercept, but then the x-intercept point itself is actually 2, 0. And I believe in your WebAssign they're going to ask you to enter the x-intercepts and the y-intercepts in full point form like this: parentheses, the x-coordinate, comma, the y-coordinate. Now, point to remember, the y-coordinate for every single x-intercept in the universe is 0. And the x-coordinate for every y-intercept in the universe, since that's on the y-axis, the x-coordinate is 0. And this is confirmed by the fact that the x-axis, the equation in the coordinate plane of the x-axis, is just a simple little horizontal line, y equals 0. It's y equals 0 because the y-coordinate for every single point on the x-axis is 0. And the equation for the y-axis is just x equals 0, confirming that the x-coordinate of every single point on the y-axis is 0. So again, we found the x-intercept point of this first equation by plugging in 0 for y and solving for x, and then writing it in the in the ordered pair format. Well, similarly, if we wanted to find the y-coordinate here, the y-intercept, we would let x be 0 and then solve for y. So writing out this equation again, y equals negative 3 times 0 plus 6. Well, negative 3 times 0 is just 0, so we have y equals 0 plus 6. And of course, any number plus 0 is just itself, so we discover that the value of the y-intercept is 6, meaning that the graph of this line crosses the y-axis at y equals 6. It is actually correct. Let's talk about this. It's a matter of grammar and terminology. Depending on the context and the circumstances, it is correct to say that the y-intercept is 6. It's also correct to say that the y-intercept is the point 0, 6, 0, 6 in parentheses. It simply depends on the context. It depends on what is required or expected in the particular problem or situation, which one is correct. Sometimes you can say just the number. Oh yeah, the y-intercept is 3. But in other situations, you need to specify the entire point, that is 0, 3 in parentheses. So it just depends on context, and oftentimes WebAssign will expect you to enter the entire ordered pair format. So once again, we found out the y-intercept is the number 6, but as a point, that is 0, comma 6. Well, let's get this here. 0, comma 6. Okay. So the x-intercept is 2, comma 0 in parentheses. The y-intercept is 0, comma 6 in parentheses. And again, we found each of the intercepts by letting the other variable be 0 and then solve for the variable for which we were trying to find that intercept. All right. Now, what about for the circle? It's a little bit more involved because you got x squared plus y squared equals 4. Well, if you remember, we solved this equation a while ago for y, and that we got y is equal to plus or minus the square root of negative x squared plus 4. So if we want to find the x-intercepts, then we've got to set y equal to 0 and solve this. And that means if we make y equals 0, we got 0 equals plus or minus the square root of negative x squared plus 4. And to solve 0 is equal to the square root, we're going to square both sides. And when we square both sides, the plus and minus goes away because a positive squared is positive and a negative squared is positive. So we have 0 equals the square root, but then when we square both sides, we simply get 0 is equal to negative x squared plus 4. And now we have to solve for x. Moving the x squared to the left side, in other words, adding x squared to both sides of the equation. 0 plus x squared is x squared, and negative x squared plus x squared cancels out, leaving only the 4 on the right side. So we have x squared equals 4. And the simplest way to solve this, again, is to take the square root of both sides, giving us x equals, and here you have to remember, so important, plus or minus. It's not just x equals 2, x equals plus or minus 2. Why? Because positive 2 squared gives you 4, but also negative 2, that number squared, negative 2 times negative 2, the negatives cancel, and also give you positive 4. So the equation x squared equals 4 has two real number answers, positive 2 and negative 2. Therefore, there are two x-intercepts. There is negative 2, comma 0, and there is also positive 2, comma 0. So, that's what we have. And that same process can be done again. Instead of solving this x squared plus y squared equals 4 equation for y, we can just come back a second time and solve it for x. And when you do, you'll actually get the same form, just with the variables swapped. You'll get x equals plus or minus the square root of negative y squared plus 4. And then to find the y-intercepts, you just set x equal to 0, and you have the y-intercepts. Or you can just use this equation right here, the one that we have just right here. You could use this equation easily, quite naturally, again, and just set x equal to 0 here. And when you set x equal to 0, you get y equals plus or minus the square root of negative 0 squared plus 4. Well, 0 squared is 0, and negative 0 is 0, and 0 plus 4 is just 4. Plus or minus the square root of 4, well, we know the square root of 4 is 2, so then we get that y equals plus or minus 2 also, meaning that there are, similarly, just as there were two x-intercepts, there are also two y-intercepts. So negative 2, 0 and 2, 0. Oh, I'm sorry. Talking and writing at the same time. That's risky here. Let's see if I can no, I cannot erase, apparently I can't just erase part of this, I have to erase all of it. So let me correct that. I just rewrote the x-intercepts. The two y-intercepts are 0, -2, and 0, 2. And now I'm going to show you on Desmos one more thing here. What is so nice in Desmos is how you can see these intercepts. They've already got the nice little gray points right here. You can see them, and when you point at them, they highlight, and I'm going to click at them, not just point at them. I'm actually going to click them, and this is so nice how you can get that. There you go, right there. No algebra needed. You just verify those are the x and y intercepts. However, I mean, this is nice, and it's excellent, fantastic facility available to us with this free online graphing utility. But I do want you to know that everybody in the course is going to have to demonstrate algebraically determining x and y intercepts. For instance, on the test, you're going to have to find x and y intercepts, and it's not just enough to point at it at Desmos and click on it. You're going to have to show that you can do it using algebra, as we just went through together. So we have talked here together about how to graph things using either Desmos or a TI-84. And many of you will probably be using both this semester. That's fine. We've talked about finding solution points and verifying whether a point is a solution point or not for an equation. We've talked about how to find x and y intercepts and how to graph various different kinds of equations. I'll show you one more thing on Desmos here also before we end this session. The square root key on Desmos, it looks a little odd. It's down here at the bottom. It almost looks like a check mark, but it's actually a square root. So for instance, if we wanted to graph y equals the square root of x, I'd hit y equals, and then I would come down here to the very bottom right next to the pi key and click this thing. It looks like a check mark. It's actually a radical sign. Click on that, and there you have your square root symbol. And then I input x into that, and so now we have y equals the square root of x. I'll get rid of these other two graphs so you can, no, it's not the one I want to get rid of. Y equals the square root of x. There we go. Different color this time because it's different position in the vertical line up there. So there's y equals square root of x graph for you very nicely. And I do think you're going to enjoy using Desmos if you haven't done it before. There's always a learning curve using something new, but I do believe you're going to find it very useful and very helpful. So that pretty well concludes this lesson. I do hope this has been helpful for you in learning the basic material of section 1.1. And this is John Grubbs, your instructor, if I didn't identify myself sooner, in Math 171-41. So we're going to sign off here, and I hope you have a good rest of the day.